Hello, I'm Feng. Our group topic is detective novel author identification on Spark. In daily life, we found that young people tend to follow different works by the same author. We think despite different novels of the same author are different in content, there should be an obvious unified feature, and the feature is exactly what their followers like. To confirm this, we choose to learn and identify detective novel authors with Spark as our topic. We choose three of the most popular detective novel authors: Edgar Allan Poe, Arthur Conan Doyle, and Dame Agatha Mary Christie, and their works as our dataset. This is the overview of our project. There are four crucial parts: generating our datasets, data exploring and mining, natural language processing, and training model, and I will introduce them in detail. Firstly, we need to make our own datasets. We download these books on the left from the internet in TXT format, and after cleaning, we cut the sentences by punctuation and save it into a new CSV file, which includes three information: ID, text, and the corresponding authors. All the sentences from the three authors are shuffled. The ratio of the training set and test set is 8:2. As you can see in this slide, this is the input format on the right. And in this picture on the left, each author has around 8,000 sentences in our dataset. The proportion is close to 1:3. In natural language processing part, we choose tokenizer as our feature transformer and word-to-vect as the feature extractor. The methods we use are from PySpark ML feature library. Tokenization is the process of taking a sequence and breaking into words. We use basic sentence tokenizer at the beginning and find it reserves all words including the same meaning as one. Then we choose tokenizer, choose the advanced tokenizer. Since we only want to reserve important words which include the feature of the author, we lemonize words, remove stop words and punctuations, and strip of HTML and digits. There are several ways to transform a BOW to a vector, like TF-IDF and word to vector are two of the most popular ways. Since we can get better result with word to vector, we choose it as our final choice to train our model. Word to vector is an estimator which takes a sequence of words representing documents and trains a word to vector model. This model transforms each document into a vector with the average of all words in the document. And we use the vector as our features for training and identifying.
Hello, I am Jiarui and I will continue with our presentation. Now we can start preparing model training. First, we divide the data into a training set and a validation set in a 3:1 ratio. Afterwards, the training is based on a logistic regression model, which will take some time. After that, we load the test file, generate word-to-vector features on the test data, and finally load the model and generate the test predictions. Next page. Next is the results presentation section. We plotted the Unicode word cloud for each writer and analyzed the average sentence length, revealing Allan Poe's Unicode font list for long sentences. We also extracted their favorite words. Next page. There are four indicators of accuracy, precision, recall, and AFRI score selected to evaluate the model's performance. The results are shown on the left. After testing, we know that non-accuracy is about 35%, which is much lower than the accuracy of our model, which indicates that our training is effective. We can see the results of the model running on the test set. Next page. Furthermore, to test the prediction effect of the whole article, we selected three additional novels to test. The figure shows that the model achieved a significant fitting effect and prediction ability, successfully predicted the three novels' respective authors. Of course, Allan Poe's style of writing is the most distinctive and also the best identified. Next page. Then, based on PySpark and the same dataset, we selected the same out-of-state models to compare their performance with logistic regression models. The results obtained are shown in the picture. We can see that Logistic regression and naive Bayes have more significant advantages than the other models in dealing with the NLP problems. Next page. Now to conclude, Spark is a great multi-language engine for data science and machine learning. In this project, we got familiar with using Spark to complete NLP problem and machine learning work, which is a valuable tool for the future work. In addition, as a detective Feng, this model will be helpful when I want to reread books from these authors or when I want to read new books. This is all about our presentation. Thank you for your listening.